All right, let's just build a machine learning model and see what happens. Okay, so I'm gonna go ahead and do some quick notebook cleanup here. Just basically, not a lot. I'm just gonna add a header. Okay, I'll call it maybe machine learning classifier. Classifier is a type of model. Why are we using a classifier instead of a regressor? It's because it's what we're trying to predict. Okay, if I come up here and add a new text header, I'll just call this, I think sometimes I like to call it data prep or data exploration. Data wrangling is also a term that you can use. Wrangle your data and get it ready. We'll worry about comments later. So I've got my data frame and it's ready for machine learning. Now, we've got to split the data into X and Y. Okay, and if I look at the data frame, well, this is before pd.getDummies. We want to look at it really after. You can scroll all the way to the end and we see income greater than 50K. That is what we're trying to predict. We're trying to use the other columns to predict it. So the idea here is that if you know the census information, I guess it's a question really, can we use that to predict whether someone makes more or less than 50K? I'm not sure when this data set originated. You can always go back to your data source. It's always important to know your data source, the UCI machine learning repository. You can see that it was donated in 1996, so it's certainly, oh, here it does say it was done in 1994. Okay, so we're moving up in years, so this is like, wow, 27 years old at this point. Okay, always keep your data sources in mind. So again, if I just do this blindly and I'm like, okay, I want to do x equals df.iloc all rows, all columns up until the last one, and y equals just the last column. All right, and that's the correct split. And now I need to build a model. Well, this is a classifier because that last column is all zeros and ones. And that's not regression, okay? Regression is when you have continuous numerical data points, okay? Think of a regression line. And, well, think of it like a standard one, a straight one, like a straight line. But, and I will get more into these models, in the next lecture, but let's just say for now that logistic regression is the complement to linear regression. It does the same thing. The only difference is that it splits the data into 0 and 1. So at the very end, it's just going to say like, hey, here's this numerical algorithm that we have, and I get some number like 7.3185. That's a 1. And if it's negative 2.1, it's going to be 0. So it splits everything into 0 and 1. Okay, and it does that using the sigmoid equation. All right, let's just build it for now and get more on the model details later. So I'm not sure if I ran these, just run them. And now, how do I do it? So I've got to import logistic regression. So that is from sklearn.linear model. It's still linear. Okay, import logistic regression. Now this is just like, I feel like it's not a good name for the machine learning community because it is a classifier, not a regressor. Okay, and what we're going to do is build a model now. So we do the following steps. Model equals, now really I should split into a training and test set. Like we know better at this point. So let's actually use cross-val score. So from sklearn. I believe it's model selection, import cross-val score. There it is. You can still initialize the model like this, it's fine, right? You can do any variable assignment that you want. I mean, call it whatever, I like to call it model. But now when I do cross-val score, okay, I want to put, I think the model goes first, then X and Y. Now previously we put in scoring for the root mean squared error. And you certainly could here with accuracy. Okay, so what accuracy does is it gives you the percentage of correct values, right? If it's either 0 and 1, We don't want to know how close it is to the right value. We just want to know, did they get it right or not? Well, guess what? That's the default here. So it's really nice for classifiers that you can just do it like this. Now, this may or may not work. So let me press Shift Enter and see what happens. Yeah, max number of iterations reached, convergence warning. This happens with logistic regression and this current iteration of sklearn, logistic regression. We're going to change max iter to 5,000, usually does the trick. And what that does, and just give you a sense of how machine learning models work, it actually, okay, we did not get the perfect 1.0 that I was expecting. Very interesting. So it should have gotten 1.0. I'll explain why in a moment. It got like a respectable score, but what the max iter means here, like when these machine learning models are run, they just start with like random weights, like random multipliers, right? You have all these values in the column, you got to multiply them by something. So just pick something random, like negative 0.21853. And then it looks at the result and says, oh, it's too high, too low, and it adjusts them. So how many times do you adjust? This says no more than 5,000. So maybe 5,000 wasn't enough. Let's see if I up it to 10. And again, we are paying a little bit of attention to the time because, yeah, no different. It's building like, remember, it's building 5 models on top of, we already figured 3 million entries. So we're looking at now an order of like 10 million computations being made. You could say, yeah, computations is fine. Okay, well, let's see what happens with XGBoost. Okay, so from XGBoost, we're going to go ahead and import the XGB classifier. That is the complement to the regressor. And then we can do the same thing. Okay, it's just, I'll just use this even. Instead of model, which is defined as logistic regression, I can just put an XGB classifier. And then I can put in X and Y. Readability matters. I think the upper code is a little more readable, but it's the same thing. Okay, let's see how we do. The XGB classifier does not need, oh man, an issue with the feature name. Okay, I'll have to come back to that. Okay, that's a surprise. So sometimes there can be little things that happen. And this is the reality with dealing with data. Sometimes things are a little messy. It doesn't like there's an issue with the feature names. That's weird. Like we should be able to name the columns whatever we want. Okay, so I'll come back to that point. But let me just tell you why we should be getting 1.0, which we didn't get here. Look up at the data. Okay, and this shows you how the machine learning models maybe aren't as smart as they should be always. If we're trying to predict this last column, assuming I wrote it right, the column before tells you. I mean, it's obvious. Like, this is going to, if this is 0, then this is 1. If this is 1, then this is 0. Okay? So it's actually easy to compute. Issue with logistic regression is that it's multiplying all the columns, and I mean, is it easy to multiply it out to do that? We can actually look at the data set. Let's just do a quick math dive here. Berkeley Coding Academy is not math heavy. I'm a math teacher though, and I love math. Well, if you just take 0 of this column and add it, you get this. But what if you have 0? Then you need to take 1 of that to get 0. So is there a way that you can, I think the correct word is parameterize the equation to send all 1s to 0s and all 0s to 1s just by multiplying them? Well, if you take the 0 to go to 1, you multiply that, you're just going to get 0, but you can add 1 to it. Okay? So if I add 1 to 0, that's like a plus b, it'll give me the 1. And what do I need to add here to get 0? Well, it's negative 1. So if I multiply this column by negative 1 and add 1 to it, I'll get the correct result. So it is actually easy to do. And sometimes like the models don't do always what you would expect. Okay. But we built our initial classifier, got this interesting arith XG boost. So I'm going to take a look at it and get back to you.